Storage structure. So the storage structure of a computer systems basically are divided into the main memory and the secondary storage. Now, the main memory is the only large storage media that the CPU can directly access. So characteristics are, it should be random access, or it is random access, typically volatile. When you say volatile, you've got the temporary storage. Okay, your data is there unless there is a power. When the power is gone, your data is also gone. That is the volatile. Okay. Now, typically, random access memory in the form of dynamic random access memory, or DRAM. The second one is a secondary storage. So extension of the main memory that provides a large non-volatile storage capacity. When we say non-volatile, that pertains to permanent storage. Your hard disk is a non-volatile storage. So next would be the secondary storage. Secondary storage is the extension of the main memory as mentioned earlier. Okay, and it includes the magnetic disk. So magnetic disk or hard disk drive is a rigid metal or glass platters covered with magnetic recording material. So disk surface is logically divided into tracks, and each track are divided into sector. Okay. Now, the disk controller determines the logical interaction between the device and the computer. So as mentioned earlier, we have here a controller because hard disk drive is one of the peripheral, and it should have their own controller called disk controller. Okay. So another storage is the NVM, or non-volatile memory devices, which is faster than hard disk and also a non-volatile. So various technologies becoming more popular as capacity and performance increases while lowering the price. Okay, so let's have some notation review about the storage. Basically, the basic unit of computer storage is in a bit. Okay, so when you say bit, we are talking about values of 0 and 1, or in binary. Bit is actually binary digit. Okay. Now, a group of 8 bits is 1 byte. So a byte is 8 bits. And on most computers, it is the smallest convenient chunk of storage. Okay. Another term aside from byte is word. Okay. So which is given computer architecture's native unit of data. A word is made up of 1 or more bytes. Okay. So you also have kilobyte. And 1 kilobyte is equals to 1024 bytes. Same thing with megabyte, or MB, that's 1024 raised to 2 bytes. You also have the unit of data in gigabyte, terabyte, petabyte, and so on. Storage hierarchy. So storage system organized into hierarchy. So this is based on the speed, cost, and volatility. So for volatility, we have covered earlier, volatile and non-volatile. Volatile, temporary storage. Non-volatile pertains to permanent storage. We also have the term caching. Caching is copying the information into a faster storage system. Main memory can be viewed as a cache for secondary storage. Okay, so when we move our data from the secondary storage, or from the hard disk going to a faster storage, we call that process as caching. Okay, so also we have mentioned about the controller or device controller. Now this controller is being managed by a device driver. Okay, so device driver for each device controller to manage I/O, and that communicates directly with an operating system. So it provides a uniform interface between the controller and the kernel, or the operating system itself. Storage device hierarchy. So this would be the hierarchy of the storage devices, and let's divide it into 2. Okay, so memory, cache, and registers, these are classified to be under volatile storage or temporary storage. Now, non-volatile storage includes the non-volatile memory, hard disk drives, optical disks, and magnetic tapes. Okay? Now, registers, cache, and main memory are classified to be a primary storage. Non-volatile memory and hard disk drives are secondary storage. And optical disks and magnetic tapes are classified to be tertiary storage. Now, when we start from the bottom on magnetic tapes or tertiary storage, as we go upward, okay, so the access time is increasing. You've got faster access on the primary storage, and then secondary storage down to the tertiary storage, the access time is decreasing. Now, on the opposite, if we look at on the storage capacity, as we go higher on the hierarchy, okay, so the capacity or the storage capacity is limited. Okay, so from magnetic tapes having the larger capacity, going up to the main memory, which has a limited or smaller capacity. Okay, so basically for the storage structure, we have the main memory or RAM. So program must be loaded into the RAM to run the program. Okay, so instructions and data fetched into the RAM or from the RAM going to the registers. So RAM is volatile and medium-sized and speed. Okay, so other electronic volatile memory is faster, smaller, and more expensive per bit. So that includes, of course, the registers and the CPU cache. Okay, so non-volatile memory here, permanent storage, is slower, larger, and less expensive per bit. So that includes electronic disks, magnetic disks, what else? Optical disks and magnetic tapes. So how a modern computer works. Okay, so basically the modern computer are still based on the von Neumann architecture. Okay, so you've got the CPU and all the instructions are being loaded into the memory. So that is from the device. Okay, so from the I/O devices or peripherals, so information or data will be fetched and moved into the memory. And the CPU directly communicates with the RAM. Okay, so there is a data movement between the CPU and the memory. So each instruction being executed by the CPU is from and to the memory. Okay, so the CPU initiates I/O requests, okay, data, and interruption, and it will be loaded into the memory. So basically, when we execute program, we fetched it from the hard disk, load it into the RAM, and then the CPU will get it from the RAM. Okay, so load it into the cache and then execute. All right. Now we have the next term, which is DMA or the direct memory access. So we've got DMA here. Okay, so from the device, your data is loaded into the faster access memory. That's DMA or direct memory access. So used for high-speed I/O device able to transmit information at close to memory speeds. So device controller transfers blocks of data from buffer storage directly to the main memory without the CPU intervention. So going back from the diagram here, okay, so if you will observe, the CPU is not part of the data movement, okay? So the CPU is not aware about the data movement from the device going to the memory, okay? So only one interrupt is generated per block rather than one interrupt per byte.